Welcome back to the deep dive. So if you've ever wondered what's stopping a server farm from, melting down, or how pharmaceutical storage stays so precisely calibrated, you're actually looking at the kind of tech we're covering today. We are diving into the NTI E-RTDT-240. It's a 100 ohm platinum RD transmitter. I know it sounds like pure industrial jargon, but it's a critical piece of infrastructure.
It really is. I mean, this device is basically an unsung hero. It solves a really fundamental problem in monitoring critical environments.
Which is what?
Well,
Exactly.
how do you get hyper-accurate temperature data from somewhere far away, maybe a place with a lot of electrical noise, all the way back to a central monitoring system without that signal getting messed up?
Right, without it degrading.
Exactly. So our mission today is to really understand how this one little transmitter acts as that critical, reliable link in these big NTI monitoring systems.
Okay, so let's start with the basics then. What does this box actually do?
At its core, it's a translator.
A translator.
Yeah. It takes the input from a 100 ohm platinum RTD sensor, that's a resistance temperature detector, and it just converts that raw measurement
Into something usable.
into a standardized usable signal. It's built specifically to connect those sensors to the bigger NTI systems, the E2D, E5D, or even the big enterprise ESMS 16U.
And it's not just plug and play, is it? There's a specific setup.
That's a good point. To get a full working setup, you actually need three things. You need the E-RTDT-240 itself, of course.
Okay.
Then you need the external RTD sensor probe, and also the ES420MA24V unit. That conditions the signal input.
And power. How does it get power?
That's the neat part. The whole system is loop powered directly from the main monitoring unit, the E2D, 5D, or 16D. It really simplifies the deployment.
Okay, now let's unpack the jargon. 100 ohm platinum and that 420 MA standard. If you're not in industrial automation, those are just numbers. So why 100 ohm platinum? What's special about that?
It all comes down to precision and stability. The platinum element is incredibly stable over long periods, even in tough conditions. And its electrical resistance changes in a near perfectly straight line as the temperature changes.
So it's predictable.
Very predictable. And for this device, that gives you an accuracy within plus or minus zero point 0.8 degrees Fahrenheit. It's a really tight band.
And that sub-degree accuracy, I mean, that's where the real value is, isn't it? Why is that so important?
Well, think about something like a modern data center. Even tiny little changes in cooling, things a cheaper sensor might completely miss, those can lead to chronic damage or even failure over time.
So it's about prevention.
Absolutely. That 0.8 degree margin means the system can react before a minor fluctuation becomes a catastrophic problem. It's preventative maintenance versus a full-blown emergency.
Perfect. Okay, let's talk about the signal itself, the 420 milliamp standard. Why use that instead of, say, a simple voltage signal?
That's the key for long cable runs. A voltage signal degrades pretty badly over distance. Imagine running cables hundreds of feet through a factory floor with tons of electrical noise. It's like a weak AM radio signal fading in and out.
Right, you lose the information.
You lose it. But the 420 MA standard, that's a current signal. Current is way more robust against resistance and noise. It basically guarantees the signal that arrives at the monitoring station is identical to the one that left the sensor. It's all about data integrity.
That makes so much sense. Now, this specific model, the E-RTDT-240, it's focused on a range from 30 up to 240 degrees Fahrenheit. Why would an engineer pick this one when there's another model, the E-RTDT-140, that goes way colder, down to -20?
Yeah, that's about specialization. It usually means you get better resolution. The 240 model is optimized for hotter environments. Think about steam lines, certain manufacturing processes, or just really hot equipment cabinets.
So you're trading a wider range for more detail in the range you actually care about.
Exactly. By narrowing that focus to 30 to 240 degrees, you often get slightly better signal fidelity right in that specific operational window.
And physically, this thing is built to last, too. The specs say it's in a single gang, weather-resistant enclosure, it's rugged.
It is. It's designed to be installed in harsh industrial cabinets or even outdoors, not just a nice clean server room. Plus, it has all the regulatory stuff you'd expect, the CE approval, TAA compliance. It's ready for government and big commercial jobs.
So when you boil it all down,
At the end of the day, the E-RTDT-240 is that workhorse translator. It takes the physical world temperature and turns it into a super reliable standard electronic language. That 420 MA signal guarantees the big systems have the precise data they need to keep everything running smoothly.
And that translation, well, that's what keeps the lights on, keeps the cloud running, and the supply chain moving. So the next time you rely on something that needs a highly controlled environment, just remember there are these small, precise devices like the E-RTDT-240 running the whole show behind the scenes. It really makes you wonder what other hidden, hyper-accurate tools are securing the infrastructure all around you that you never even think about.